be studying some things about geology. So, I hope you enjoy. We've got a lot of interesting things to talk about, so I guess we'll talk about possible geoengineering actions. So there are a lot of different ways that you can geoengineer. You can do the most common way that people are talking about, or the most dramatic way I'd say, is solar radiation management. Solar radiation management is basically the idea that, when you put little particles in the air, it reflects sun back, and when sun isn't coming onto Earth, it's going to make the whole Earth cooler. Duh. So, like volcanoes, when they erupt, they actually cool down the Earth for a period of time because of all the volcanic ash and dust and shit in the air. That cools down the Earth. So, you could do that yourself. And then you would make, it's like people want to put aerosols into the air and then reflect more sun away. This is the quickest way. It's also the most dangerous way because we don't know what would happen. Okay. Then the other safest and slowest way is through carbon sequestration, which is also just like carbon capture and storage. So basically, you take the carbon out of the air and then you put it like through engineering systems back into the earth, like in the soil and the water and stuff. This is actually shown to be like actually really effective, but it's slow and it's expensive. Then there's also the possibility of cloud seeding through nucleation sites. That's also kind of risky because as it kind of serves the same purpose as the aerosols, but except it's like a little bit better because you're not putting just like a bunch of random aerosols into the air. Instead, it's like actual clouds. But then it's like, what if like anyone could just someone could just put a cloud over your home, and then you'd have a cloud over your home, and that would be kind of weird too. And that's also pretty expensive. So those are some geoengineering things. But we should also be cautious about geoengineering because with geoengineering, you don't really know what you're doing. It's like you're fundamentally altering Earth's natural systems, and that, that could be unethical. We don't know. It's kind of hard to know. But moving on. Okay, let me tell you about how the Earth regulates the temperature. So the Earth is generally really good at regulating the Earth's temperature because we basically absorb like 90%. The ocean absorbs like 90% of Earth's heat, and then it also stores a lot of carbon, about 30% of the carbon dioxide that humans emit. So it's great, it's doing great. But right now we've put too much carbon into the ocean, so it's kind of getting overwhelmed. And then also what makes the ocean such a good buffer for climate change is that it has this natural circulation where it circulates heat, and this is usually caused by differences in density of water, and differences in density of water are caused by differences in like salinity of water. So if water is more saline, then it's going to be heavier, denser, and then that dense saline water is usually in the north, and so it gets cold, and then that cold water turns into ice. It sinks. As the water sinks, it's going to bring warm water in to fill the space where it sank. So there's this kind of constant revolving circulation thing. The issue with climate change, though, is that it's melting the ice. So all that stuff that's sinking to the bottom and then causing that warm water to come through, it's no longer doing its job. So the Gulf Stream is one of the most popular circles, like revolving streams, and it's kind of disappearing, or it's not working as well. And this is bad because that also, then we're destroying one of our natural systems of being able to decreases like a planet's ability to reflect sunlight away from it. So it lowers the albedo of Earth, and then that causes more melting of the ice. It's a feedback loop, not good at all. What's also interesting is that with more things melting, permafrost has begun to melt as well. Permafrost is basically like in really cold areas, the ground beneath the ground surface has become frozen. So you have all this frozen ground beneath you. But when that starts melting, as it has, all this ground is releasing a bunch of trapped gas, which includes methane, which is a greenhouse gas, and that causes more global warming. It also releases germs that are old, germs that we don't know about. And then this also causes the loss of habitats. If snow ice is melting, the polar bears are done. Greenland's done. Right. Okay, and then we also know that the climate is actually definitely getting worse because there are ice cores. Ice cores are known as climate proxies. Climate proxies are pretty much any kind of other way, like a natural resource of Earth that shows you how the climate has changed. Oh, I don't really it's not a great definition. Let me look up the definition of climate proxy. Climate proxy definition. Climate proxies. This is AI overview. Sorry, it's a little counterintuitive that I'm using the AI overview to explain environmental problems, but you know what? It shows up on Google. I don't know what I'm supposed to do. Okay, so climate proxies are natural preserved records such as tree rings, ice cores, and sediment layers that act as indirect measurement of past climate conditions before instrumental records began. Okay, so ice cores. Ice cores work because you have like a thing of ice that's been taken from, and it shows all these different layers, and you can see, most importantly for this research, you can see where trapped bubbles have been frozen into the ice. So when snow melted, it also melted. Sorry, when snow froze, it also froze those bubbles, and there is air from hundreds of thousands of years ago trapped in this ice. You can take it and you can find out how much carbon dioxide was in there. So take all these ice cores over time and you can see the actual fluctuations in temperature, because temperature and carbon dioxide are extremely related. You can see the fluctuations of temperature as ice ages change. Nowadays though, the past 250 years, aka starting at the Industrial Revolution, the ice cores have been showing increased carbon dioxide emissions, going up, unprecedented levels of CO2 emissions, which shows, that human development and human industrial development specifically has been detrimental to climate change and the influx of greenhouse gases and the relation to the temperature of the entire Earth. But it's not all useless. It's not all useless. There are still things we can do. I don't live in Colorado. There are still things we can do. Okay. Guys, to be honest, I literally only filmed this video because I really needed to study. But I hope that the rambling relaxed you, or that you learned something. Because guys, climate change is real, so don't pretend it's not. Don't pretend it's not. Read a book. Look at graphs. The evidence is 100% out there. Trust science. scientists. You know why you should trust scientists? Scientists don't want to do anything else except be right. They want to ask questions and know what's up. They're not really, I mean, some good scientists don't let biases influence their results.